All right, welcome everyone to Building Predictable UI Components on the Lightning platform. My name is Adam Patinsky, and I'm a UX engineer on the Lightning Design System.
And I'm Jade Penning. I'm a principal UX engineer on the Lightning Design System mobile team.
So before we get started, I'm sure you've all seen this slide, but just make sure to make any purchasing decisions based on what's currently available in the product. Luckily, today what we're going to be talking about is available, so you shouldn't have to worry about that too much. So we're going to be talking about a topic today that I think everyone can relate to. I know I can, and that is user interfaces are complicated. They're hard to debug. They're hard to test. You have many people on your team contributing to them. They have to work on many different browsers. They're just like complicated, and it can be very frustrating. So today we're going to talk about 2 or 3 problems that you might be encountering in your components while you're developing, and then some solutions to those problems to hopefully make it a little bit easier. So we're going to jump right in. So the first problem you might be encountering is around state. You might be asking questions like, why didn't that component update? Or how do I get this component into that state? And it can be very frustrating to debug these problems. The next thing we have is around logic. And you might be asking, where's the function that does that? Or why did this component run that function? Or it'd be great if this component could do the same thing as that component. Or isn't this controller the same as that controller? And again, these things you can spend so many hours debugging problems related to these questions. And third are some issues around composability. You might make statements like, I wish I could use part of that component in this component, or I wish I could use that component with one small modification, or why is this component doing that? So the premise of our talk today is that we can make components less complicated. Anyone telling you that they have a solution that's just going to make all your bugs go away and just everything's going to work great is probably lying to you, but we have some things that I think if we follow these patterns, they're going to make things a lot easier to understand and much more predictable. So to demonstrate the things we're going to be talking about today, we built an app. It's a pretty fun cat sharing photo app called Instacat. And this app is made up of, if you look at it like in Lightning component terms, we might have our top-level application, and then we have a feed. And inside that feed, we have a bunch of feed items. And each one of those feed items is going to contain a header, which has like the user avatar and image. We have the actual image itself, and then we have the footer. And the footer has things like likes and comments and a few other things. And this is actually the component we're going to focus in on today. And I know it seems like really simple and probably not that important, but I think there's actually quite a few things in here that we can improve to make much more predictable and easy to understand. So to talk about our first topic, Jade's going to introduce that.
Yes, hi everybody. So the first thing we're going to talk about today is making your components stateless. And what I mean by stateless is, say we have our application here. Currently, the blue boxes represent everything in our application that is managing its own state. And in Aura, these are private attributes. So currently, since all of these are managing their own state, things can get kind of complicated as your app grows because all of these different places are maintaining their own state, and there's no one single place to keep your state organized and to keep it persisted through the session. So what we're going to aim to do in this first section here is we're going to change this structure up so that instead of each component having its own state, we're going to change it so that their state lives at the top level of our app, and parts of the state that each component needs are going to be fed into each respective component. To show off how we're going to simplify that in code, let's take a look at our code. So here we have our feed item, which is that whole Instacat feed item. So we have our image attribute, we have our image header component, we have our image component, and then we have our feed item footer. So this is where we're going to dive in, and we're going to do some optimizations here. So when we look in our feed item component, we have our ID attribute, we have our comments attribute, which is an array of strings, and then we have our show comments attribute, which is a Boolean value. And you'll notice right now that you'll see this access equals private. And in Aura, that's kind of an indication that each component is tracking something internally. It's tracking internal state. So we're going to optimize this code to remove that private attribute and to make that state global. So as we go forward here, here's the actual printout of the comments. And what we're doing here is just we have this little logic around the show comments variable, where if it's true, we show the whole list of comments. And if it's false, then we only show the first comment. So, and lastly, we have a button here, which when it's clicked, it fires off this toggle comments method, which is either going to show or hide the comments. It's going to reverse that logic depending on the current state. So when we jump into our feed item footer controller, our toggle comments function, yeah, it just does that. It gets the current state and it flips it to that whatever the opposite of that Boolean value is. So this all works fine and good, but the problem comes in, what happens to that show comment state when the component is destroyed? So to show off what I'm talking about when I say that, let's look at our app and have a little scenario here. So the user's going to tap, they're going to load up Instacat, and they're going to tap show comments on that first item, and they're going to see the full list of comments. But then they're going to scroll down the feed, and the previous feed item is going to be destroyed once it's off screen. So when the user scrolls back up and they get back to that first item, the feed item is recreated, but the private show comments attribute has been reset. And why that's happening is because the state is being managed currently in the individual component, and when it's destroyed and recreated, that state is also lost and it's reset. So how can we go about fixing this and improving this? So following our first principle of stateless components, we can have our parent, our top-level component, manage that state, so it's stored and persisted through the session. So we're gonna change our code. We're gonna add a feed. Going back to our feed item component, we're going to add an attribute called show comments, which is going to be this global show comments state we're going to add in. And that state's going to persist, and it's never going to be lost if the user navigates away from the individual feed item component. So when we go into our feed item footer, what we can do now is, since we're passing in that attribute and it's no longer an internal attribute, we're going to remove that private attribute from the code that we had before. It's no longer there, and we're good to go. But you might be thinking now, what happens to the controller? Because previously, we had that toggle of logic, and we were updating the private state. But now we don't have that concept anymore. So we're going to get into that in our next topic when we talk on logicless components. But to summarize what we covered so far, we've made our application more stateless by moving the state out of the child component and into a permanent place in the top level of the application. This keeps state predictable in one place, and it helps persist data as our user navigates through the app.
Great. So the next thing we're going to talk about is logicless components. And I know that kind of sounds like an oxymoron because we're building an application that obviously has logic in it. But what I mean by that is if we kind of look at this diagram here, now each one of these blue boxes represents like some controller code or some logic. And let's say something happens in the footer. You click a button, and it does some stuff, and it dispatches an event to the feed item. It does some more stuff, and it dispatches another event to the feed item into the feed. And as you can see, as we get more and more of these arrows and boxes, it's going to be like really complicated to figure out like who's handling what event, and who's dispatching, and what's running what function. And so just like we did before, what we're going to try to do is move all of our logic to the top of our application, and the child components are now just going to be responsible for notifying the parent that, hey, I would like something to happen, and you should be responsible for actually making it happen. So if we go back to our feed item footer controller, we're going to now create a new global or application-wide event called Instacat Action, and it has two parameters. Type, which is a string representing what we want to happen, and in this case, we want to toggle the comments. And then a second argument is called payload, and it's just going to have any relevant information that the top-level component is going to need to do this action, which in this case, we need to know what image, so we're going to pass it the ID, and then we're going to fire it. So now we might be wondering, like, well, who's listening for this event? And luckily in our application, we only have one component listening for this event, and it's at the very top. This is called the store, and we have the controller here, and it's got a handle action function in its controller. And it's going to grab the information we just passed into the event, the type and the payload, and then it's going to get the previous state. And by that, I mean it's going to get everything that our application knew about before the user clicked the button. So the images, the users, the toggle states, like everything that was like before the button was clicked. And then we're going to get our next state, and we're going to call a function in our helper called getNextState, and we're going to pass it the previous state along with the action, which has the toggle comments and the payload. And unfortunately today we're kind of constrained for time, so I don't have time to jump into that function, but just know that's where all the logic for like actually toggling the comment went. Then we're going to save that state, and then we're going to dispatch a second. We only have two events in our application, and this is the second event. It's also global. And we're going to say, hey, the state was updated, and here's the new state. And any component that cares about that is now going to listen for that. And no, we don't have to worry about it being out of sync or some components not updating correctly, because everyone's going to get the exact same copy of the state. The data will be exactly the same, and we know exactly where that logic was happening. So what did we accomplish? We moved all of our logic to a single location at the top of our application, allowing our components to describe what should happen, not necessarily how it should happen.
So the last thing we're going to talk about today is we're going to talk about composable components and making our components more composable. The idea behind composable components is that we want to make sure that our components aren't being too specific to one certain task or doing too much. We want to be able to reuse our components when necessary, because if we had another section of our app that wanted to show comments, it wouldn't be very optimized if we had to rewrite all of the code, all of the logic, all of that markup that handled showing comments and how many they should show. So we're going to reuse this the comments code we wrote for footer comments. But to do that, we need to make a few changes. So diving back into our feed item footer, we have this unordered list, which we showed before, which kind of has the logic for how many comments to show. So we're going to take this unordered list, and we're going to turn it into a component. And we're going to call it image comments. So here is... Oh. So, sorry. We're going to... here's our new component in the feed item footer that has the image comments, and it's passing in the attribute with the comments. So going into our image comments component, here's our attribute with the comments, which is the array of strings. And then here's our new unordered list, which has that iteration, and it's just right now it's just going to show all of the comments. So we're still missing something here, and what we're missing is the logic we had before that kind of says how many comments do we show. So we're going to re-add that now. So what we're going to do is we're going to make a new attribute for our image comments component called count. And what we're going to do here is we're going to get that show comments property. And if it's true, we're going to get the length of the array of comments, and we're going to pass that in as the count. Otherwise, we're just going to show the first comment, which we're representing with the number 1. It's just so one comment. So when we go into our image comments component, we're going to add that attribute for the count. We're going to make it required. And in our ordered list, where we're iterating over all of the comments and displaying them, we're going to add an iterator attribute here, so we have access to which iteration that the image comments is doing. So what we're going to do here in the iteration is we're basically going to do a conditional for if the comment count, the current iteration, is greater than the comments that we're showing, we're only going to show the number of comments that are in that iteration. So what we've accomplished here is we've made our components more reusable and composable. We've simplified their responsibilities, allowing them to be reused and customized in different places in our app.
So we're just going to do a quick overview of what we did today. So the first thing we did is try to make some of our components stateless, and by that we mean driven by public attributes. Anytime you can drive a component by public attributes, it's always going to be way more predictable and easy to understand. Then we made some of our components logicless, and that was saying our components are going to tell the application what should happen and not how it should happen, so our logic is not buried deeply in our components. And finally, we made some of our components composable, just making them much more small, reusable, and focused. So I might be saying, like, so what? Like, our application literally does the exact same thing it did before we started, but I think we have a couple key benefits here. First of all, they're going to be much easier to debug, because now we know where our state and our logic is located, and it's pretty much in one spot. And so when you're trying to debug something and figure out like why something didn't happen right, we kind of know where to look. Second, when we're making new components or like updating components, we now have like a predictable pattern to follow. We don't have to figure out like start making up new event names and figuring out who's handling those events and who shouldn't be handling those events. So that's there. And then thirdly, something we've really found on our team that's been helpful is it's really easy to onboard people. When you start following a pattern like this, people can dig into your code base and they can pretty easily pick it up, and they don't have to start digging through like hundreds of components, looking at like all these controllers and trying to figure out who's doing what. It just makes it way easier to start being productive on a code base. So.
And these are just a few ideas. And the really great thing about what we've talked about today is that they can all be done incrementally. This isn't an all or nothing solution. You can start implementing either one or all three of what we've talked about and see how they help your team. See if they help your team understand the code better and understand the components to be more predictable. So thank you very much, everybody, for coming to our talk today. If you would like to continue and learn more information about Lightning Components, we encourage you to take the Lightning Components Basics course at this URL above. Yeah, thank you. We have a few minutes for questions.
So yeah, we'll be down, since we don't have a microphone, we'll be down here, and feel free to ask us any questions you have. So thank you very much.